In this section, we're going to discuss modularizing code. One of the main purposes of modularization code is to isolate the method code into one place and not duplicate it throughout a program. Since most methods return a value and can be used as expressions, this becomes a very powerful way of reusing the code. For example, the math.square root method can be used multiple places in a program, but only be written one time. Further, math.square root and other math functions may be unfamiliar in how to implement them. Yet the basic function, that is returning a square root, is reasonably well known and understood. Therefore, we can use them without knowing how they work. The idea is to manage or hide complexity so that programming takes on more of an approach of problem solving than manipulating details of code. Now, most of us enjoy writing that code, but we don't like the tedium. Imagine trying to write the input and output code every single time you had a program. That would become very error prone and very tedious. Write it once, get it working, and then reuse it. Some methods may be good enough to be reused in other programs. One should consider pushing them off into libraries at that point. Programmer may collect many methods and develop many libraries over a career, and in some cases, these libraries can be packaged for commercial use that others can use, either through a freeware, public domain software, or costed software that is sold for profit. All of this is made possible by using methods and managing the complexity well. Modularization is a key idea behind this isolation and reuse. When we isolate code, we want to have it in one place. The problem with code duplication is that when a change needs to be made, it has to be made every place that particular code exists. A programmer might not know all those places or may miss one in the heat of trying to change the code. Further, if a bug is introduced in one place, that bug is introduced everywhere. So a bug fix becomes even harder, because every change then has to be yet again modified. Eventually, somebody's going to forget something, and we're going to have not quite duplicated code. And that in itself is a bug. Isolated methods allow easier testing. Maybe you've heard of test-driven development or behavior-driven development. It's an idea of writing tests to validate the code. It's very difficult to do when code is scattered around and not isolated. When isolated into methods, this testing becomes much more simple. And finally, if the algorithm that the method implements needs to change, it's isolated to one place. It allows the developer to change it there, and everyone that uses that method gains the benefit of it, but without having to know the details either of the method or particularly of the change to the method. This allows more efficient algorithms to be implemented in a method that does a certain function, and that always helps your customers or your program. But again, they don't need to know the details.